G'day guys, how you going? So today we're going to be doing some physics calculations within the energy topic, and I'm going to show you three major calculations that you need to be able to do and their associated formulas. Alright, let's do it. Starting off with movement or kinetic energy. To do that, the formula is kinetic energy is equal to 0.5 times mass times speed squared. Energy is in joules, mass is in kilograms, speed is in meters per second, okay? So let's take an example. The best car in the world, a Morris Mini weighing 617 kilograms, is traveling at a speed of 30 meters per second. Calculate its kinetic energy. With all of these, I've used the color coded to match up the numbers to their formula just to help try and make it a little bit clearer. So kinetic energy is equal to 0.5 times mass times speed squared. In this case, the kinetic energy is 0.5 times the mass, which was 617, multiplied by speed squared, or 30 squared. Now, the next part is to always solve these squared first. So plug into your calculator, 30 squared, right? And you'll get 900. So then what we've got is now we can just multiply these three numbers together. 0.5 times 617 times 900 gets you 277,650 joules, right, of energy required. If you get a big number like this, often they'll ask you for kilojoules in the answer. To get from joules to kilojoules, all you need to do is divide by 1,000, because there's 1,000 joules in 1 kilojoule. So just take that number, divide it by 1,000, which gets you 277.65 kilojoules of energy for that Morris Mini. Okay? All right, so let's look at this next one, which is lifting objects up, or gravitational potential energy. So gravitational potential energy is equal to mass times gravity times height. Energy is in joules, mass is in kilojoules, gravity is in newtons per kilogram, and height is in meters, okay? So I wanted to give you a bit of a particularly topical example from this, for me being an Australian. And so, for example, a koala jumps from a tree to kill its prey, in this case, you. The koala has a mass of 11 kilograms, and it falls a distance of 3 meters. How much gravitational potential energy does it have when it was up the tree? The gravitational strength of Earth is 9.8 newtons per kilogram. So let's have a look at this koala, right? The koala jumps out of the tree onto its victim, all right, and it shreds it to pieces and kills its prey, just like drop bears like to do. So here we go. Let's try and solve this physics-based equation, because we're not here for biology. Gravitational potential energy is mass times gravity times height. Mass was 11 kilograms, gravity was 9.8, and height was 3 meters. So you just multiply those three numbers together and you get 323.4 joules. Perfect, job's done, right? You've solved for a killer koala. Next one, last one, is looking at elastic potential energy. So to do this, it's a little bit similar to the kinetic energy formula. Elastic potential energy is 0.5 times spring constant times extension squared. Energy is in joules, spring constants in Newton meters, and extension is in meters. Now this one is actually on your equation sheet. So if you see elastic potential energy, just cast your eyes over the equation sheet if you've forgotten what the formula is, okay? So let's practice. Mr. Selby's getting in shape, right? And I hope you've noticed that recently. So he's bought himself a thigh master to really bust his glutes. The spring inside has a spring constant of 1900 newtons per meter, and he can stretch the spring about 0.5 meters. What is the elastic potential energy in this example? All right, there's his thigh master. So elastic potential energy is equal to 0.5 times spring constant times extension squared. So 0.5 times the spring constant, which was 1900, times extension, which is 0.5, but we square it. Always solve the squared first, plug it into calculator, 0.5 squared, and you'll get 0.25. So elastic potential energy, not W, is equal to 0.5 times 1900 times 0.25, done. And you get 237.5 joules of energy. All right. Please remember, often these questions will give your answers in centimeters instead of meters. Just remember that 100 centimeters is equal to 1 meter. So to get from centimeters into meters, you just need to divide by 100. Okay. And those are the three energy calculations you need to be able to do. Hope this helped, guys, and I'll catch you later.